Hello friends, welcome to my channel. This is Objective Mechanical Part 4. This is for RRB, IAS, PSU and State PSC and SSCG, also for BEL. Question is, the strength of a hollow shaft for the same length, material and weight is dash of solid stuff. Here weight is constant, so strength of hollow shaft is more than the strength of solid shaft. B is our answer. Here we have to check the conditions. Two conditions are there. If weight is constant or if space is constant. Which one is asked in question? We have to check that one. If weight is constant, power transmission capacity of hollow shaft is better than solid shaft if weight is constant. And power transmission capacity of solid shaft is better than hollow shaft if space is constant. In this question, weight is constant, so strength of hollow shaft is greater than the strength of the solid shaft. For a linearly elastic, isometric and homogeneous material, the number of elastic constants required to relate stress and strain are. This one already discussed in quick review for ISR examination, strength of material. You can check it from my playlist. For linear elastic, isometric and homogeneous material, number of elastic constant required is 2. B is our answer. In GATE also this question was asked. In GATE 2015 or 2014 this question was asked. Slenderness ratio for any column. This one also already discussed in strength of material quick review for ISRO. You can check it from my playlist. P critical is pi square EI effective length square. I is mk square. K is least radius gyration. So K is, this is area, AK square, I by A root over. So here pi square E, I is AK square, L is square. We can write it as A divided by K L square. This LE by K is our slenderness ratio. So slenderness ratio is effective length by least radius of gyration. So from option, effective length of column by least radius of gyration. D is our answer. Among the following characteristics, one is not characteristic of austenitic stainless steel. Its answer is C, brittleness. A, B and D are the characteristics of austenitic steel. So C is our answer, brittleness. Corrosion resistance of stainless steel is due to A, chromium, B, carbon, C, vanadium, D, copper. Chromium is our answer. A is our answer. This question was also already discussed in quick review for production. Work hardening of a steel component reduces its ductility. Already explained in that video. You can check it. Galvanizing is done with a thin layer of zinc coating we are giving in galvanizing. So answer is A. Next question is, bronze used for church bells contains A, no copper, 4 to 8% of tin, 1 to 4% of tin, 15 to 25% of tin. Bale metal consists of copper and tin. Copper percentage 78% and tin percentage 22%. So D is our answer. 15 to 25% of tin. Here two more things are important here. For bronze, normal bronze, copper and tin percentage, its composition, it consists of copper and tin. Copper percentage 90%, tin percentage 10%. And for brass, it consists of copper and zinc. Copper percentage 70% and zinc percentage 30%. For removing thermally induced stresses in glasses, one of the following processes will be used: A. Annealing, B. Tempering, C. Hardening, D. Cold working. For removing stresses, thermally induced stresses, annealing we are using. So A is our answer. Carbon-carbon composites are extensively used. These are used for very high temperature application. So C is our answer. Temperatures around 3000 degrees Celsius. High temperature application we are using carbon-carbon composites. 111 plane of a cube is, so it is a horizontal plane, vertical plane. Then so 111 will come here in this point. 111. So from 0 0 0, if you will join, the plane is, this is the plane A and B. It's inclined to both horizontal plane and vertical plane. So D is our answer. The ability of a metal to withstand elongation or bending is known as, its answer is ductility. And malleability is the ability of metal to withstand deformation under compressive load. And stiffness is the ability of the metal to resist deformation. And brittleness, it is the property of materials which states that they do not deform under load but suddenly breaks or fractures. So our answer is A, ductility. Addition of magnesium to cast iron increases its, if magnesium percent increases in cast iron, then strength in tension increases. So ductility increases. B is our answer. Which of the following has least percentage of carbon? A malleable cast iron, B pig iron, C stainless steel, D wrought iron. Answer is wrought iron. In pig iron, 4 to 4.5% carbon is present in pig iron. Stainless steel, it's around 0.15% carbon. But in wrought iron, its percentage is 0.02 to 0.03%. All are carbon percent. And for grey cast iron, this is also important. Carbon percentage 2.5 to 3.8% carbon. For steel, maximum carbon percentage 1.7%. So our answer is wrought iron. Cementite contains carbon to the tune of carbon percent is 6.6%. Cementite contains maximum to the tunes of 6.6% carbon. Cementite is Fe3C. The atomic bond found in diamond is its covalent bond. White metal is an alloy of, it's also called as bearing materials. It's either tin base or lead base. So antimony percent is around 10%. In this question asked, white metal is an alloy of lead plus tin, lead plus bismuth, lead plus zinc, lead plus aluminum. Its answer is lead plus tin plus antimony. Antimony 10%, so lead plus tin. A is our answer. Antimony around 10%, maximum up to 10%. Which of the following generally made of high carbon steel? Its answer is A. Hammers. Hammer is made of high carbon steel. Here percentage are also important. Low carbon steel, medium carbon steel and high carbon steel. Mild steel is example of low carbon steel. And for low carbon steel, percentage is 0.45% carbon, less than 0.45% carbon. And in case of medium carbon steel, it's greater than 0.5% and less than 0.8% carbon. And for high carbon steel, it's greater than 0.8% carbon. For low carbon steel, products are angle, channel, rod. These are examples of low carbon steel. Mild steel also a low carbon steel. This is very important. For medium carbon steel, examples are clutch discs, then valve springs, And for a high carbon steel, hammer, cold chisel also asked in IAS exams, punch. So examples are also important. And this carbon percent, for low carbon steel it's less than 0.5% carbon, and for medium carbon steel it's in between 0.45 to 0.8% carbon, and for high carbon steel it's greater than 0.8% carbon. Percentage also very important. Connecting rod is generally manufactured by, this one also so many times asked in IAS and ISRO examination. In list 1 and list 2 type of matching questions, you will get this type of question. One side you will get drop forging, other side you will get connecting rod. You have to match. Answer is drop forging. Honing operation is used for high finish for a plane surface. B, inside a cylindrical surface. B is our answer. Jigs are not used in one of the following: A, location; B, clamping of the component; C, safety; D, none of these. For safety we are not using jigs. Discontinuous chips occurs. Discontinuous chips, it occurs in brittle materials. For ductile material, continuous chip. Continuous chip. For proper cutting, cutting material does not require A, higher hardness; B, hot hardness; C, high wear resistance; D, higher friction. Does not require, so high friction is not required. D is our answer. Green sand contains silica sand 70 to 85%, clay 10 to 20%, and moisture 3 to 6%, and additives 1 to 6%. So in this question, green sand contains clay percent 10 to 20%. So A is our answer. Coal dust is added to molding sands for improving of the casting. A, surface finish; B, collapsibility; C, hot strength; D, dry strength. Here we know this is also important. All four options. Sawdust is added for molding sand for high collapsibility and to improve green strength. This one also 2 times asked in ISRO examination. And coal dust, sea coal and silica flour, they are added to molding sands to increase the surface finish, for high surface finish. So coal dust, this one, answer is high surface finish. A is our answer. In order to grind soft materials, so fine grained wheel for hard material. Coarse grained wheel for soft materials. In this question, for grind soft materials, answer is coarse grain grinding wheel is used. This is also important. Fine grain grinding wheel, this is for hard material. Thank you friends. Thank you for watching my video. Thank you.